Okay, so my question is, describe how you would set up an experiment to track the motion of a block sliding down a plane with friction, and how you would analyze the data to understand the motion, make sure your vocabulary and concepts are properly used. Basically, my experiment involves creating an experiment where a block of a determined mass slides down a plane with a determined angle too, and in addition to this, I need to use a friction force against the block. In this case, I created a free body diagram, as you can see here, which uses which has the forces and reactionary forces and other relevant data that apply to the experiment. The block, first of all, has a determined mass. I assume 10 kilograms. Its weight is going down. The weight is, of course, the mass times acceleration, with acceleration being the gravity, which is 9.81. So I have 98.1 newtons as the weight. The angle of the plane is 30 degrees. Also, the normal force, which is perpendicular to the surface the object is sliding down from. And finally, the friction force, which acts against the sliding block. For this experiment, I assume, as I said, the angle of 30 degrees, the weight of the object in 10 kilograms, and a friction force of 0.25. So first of all, we need to get the x and y components, which are determined by the weight times, for the y component is the sine of the angle. In my case, it's 98.1 times sine 30 degrees, which is 49.05 newtons. Then for the force on the x component is the same, but with cosine, so it is 98.1 newtons cosine of 30, which yields a result of 84.957. But the normal force is the same as the weight of the x component. So in this case, as I wrote here, n equals the weight, which in turn equals the 84.957 as well. Finally, for the friction force, I assume the 0.25. So to get the actual friction force, we need to multiply this coefficient times the normal force, which is 0.25 times 84.957, which in turn yields 21.239 newtons. And finally, for the net force, is to basically have the weight minus the coefficient of the friction, which is 49.05 minus 21.22, which is 27.83, as you can see here. And finally, to get the acceleration of the block sliding down the plane, it is the use of Newton's second law of motion, which is sliding down, and in this case it's sliding down the plane with the addition of the friction forces. So the formula is net force equals mass times acceleration. Since we don't have acceleration, we need to we need to factor the others so that we can get acceleration, which equals the net force divided by the mass, which is 27.83 divided by 10, which in turn yields 2.783 meters per second squared. With this result, we basically got the acceleration of the block sliding down the plane. If we were to add time, so we can track each second that passes or every moment, then we can get a formula to actually measure how much the block has slid down with its acceleration after any amount of time. And since the answer is in meters per second square, which is accurate with the acceleration units, and yeah, I think that would be well. In this case, for this experiment, we actually made the curve, the little experiment, the challenge. It first begins with an object sliding down a plane, in this case a car, and this experiment we basically had to do to get the most amount of acceleration possible within the specifications of the size. And this way, when the car slid down, we of course had to measure the friction factor as well, but we wanted it to get the most acceleration possible. So in this case, I was lucky to get an experiment that we had actually done before. Thank you, that's it.